Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, variation. Here are the objectives that we look forward to achieving at the end of this topic. At the end of this topic, you should be able to differentiate between the types of variations, and you should be able to solve questions on the types of variations. Let's learn more about variations. Variation is the relationship between two or more quantities in which a change in one quantity results in a change in the other quantities. So when there is a relationship between two quantities such that a change in one quantity causes a corresponding change in the other quantities, then the relationship is referred to as a variation. Let's consider this example. Amma is a sales girl at a supermarket. Her weekly wage is 10% of her total sales in the week. What this statement means is that at the end of every week, Amma is paid 10% of the total amount of things she sold in the week. Let's draw this simple table here with Amma's total sales in the first column and her weekly wages in the second column. Let's say that this is the first week, this is the second week, this is the third week, and this is the fourth week. Now, in the first week, she made a total sales of 1,000 cedis. In the second week, she made a total sales of 1,500 cedis. In the third week, her total sales was 800 cedis. And in the fourth week, her total sales was 2,500 cedis. The point says that her weekly wage is 10% of her total sales. So her weekly wage for the first week will be 10% of 1,000 cedis. And 10% of 1,000 cedis is 10 divided by 100 times 1,000. That will give us 100 cedis. In the second week, her weekly wage will be 10% of 1,500 cedis, which is 10 divided by 100 times 1,500. And that will give us 150 cedis. In the third week, her weekly wage will be 10% of 800 cedis, which is 80 cedis. And in the fourth week, her weekly wage will be 10% of 2,500 cedis, which is 250 cedis. Now you can see from this table that Amma's weekly wages depends on her total sales. That is, her total sales determine how much she will receive at the end of the week. So if she makes a total sales of 1,000 cedis, her wage will be 100 cedis. You can see clearly from this table that as her total sales increases, her wages will also increase. As her total sales decreases, her wages will also decreases. So you can, looking at this table, we can see that there is a relationship between the total sales and the wages, such that as the total sales changes, her weekly wage will also change. Such a relationship is what we refer to as variation. The relationship that exists between two or more quantities such that a change in one quantity will result in a change in the other quantities. You can see from the table here that a change in the total sales will cause a change in her weekly wage, and this is what we refer to as variation. There are different types of variations. In this chapter, we are going to consider 4 of them. The first one we will consider is the direct variation. The second one is the indirect variation. The third one is the joint variation. And the fourth one is the partial variation. So in this chapter, we are going to consider direct, indirect, joint, and partial variations. Thank you for watching this video on Introduction to Variations. Subscribe to this channel for more videos. In the next video, we are going to tackle the first type of variation, which is direct variation. In the previous video, we considered variation and the types of variations. In this video, we are going to consider the first type of variation, which is direct variation. Direct variation. If two quantities x and y are related such that an increase in x results in an increase in y, a decrease in x results in a decrease in y, then x is said to vary directly as y. So what this statement means is that if these two quantities x and y are connected such that an increase in x will cause an increase in y, and a decrease in x will also cause a decrease in y, then x vary directly as y. Let's consider these examples. Let's consider these circles. We will call this one circle 1, and circle 1 has a radius of 2 centimeters. We will call this circle 2. Circle 2 has a radius of 3 centimeters. And we will call this circle 3. Circle 3 has a radius of 5 centimeters. So we have circle 1, circle 2, and circle 3. From the videos on mensuration, we learned that the formula for finding the circumference of a circle is equal to 2 pi r, where r is the radius of the circle. So for circle 1, the circumference is 2 times pi times r, which is 2 centimeters, and that will give us 4 pi centimeters. For circle 2, is going to be 2 times pi times 3 centimeters, and that will give us 6 pi. And for circle 3, it's going to be 2 times pi times 5 centimeters, and that will give us 10 pi. Now we can see from these circles that as the radius in circle 1 increases from 2 centimeters to 3 centimeters in circle 2, the circumference also increases from 4 pi to 6 pi. In the same way, as the radius increases from 3 centimeters to 5 centimeters, the circumference also increases from 6 pi to 10 pi. So we can see clearly from here that as the radius increases, the circumference also increases. If you look at it from the opposite direction, as the radius decreases from 5 centimeters to 3 centimeters, the circumference will also decrease from 10 pi to 6 pi. In the same way, as the radius decreases from 3 centimeters to 2 centimeters, the circumference also decreases from 6 pi to 4 pi. So, as the radius decreases, the circumference also decreases. So, if you look at it in this direction, the forward direction, we can see that as the radius increases, the circumference increases. And if you look at it in the opposite direction, we can also see that as the radius decreases, the circumference decreases. Such a relationship is what we refer to as direct variation. An increase in one quantity causes an increase in the other quantity, and a decrease in one quantity also causes a decrease in the other quantity. When you have that, then we say that the two quantities are in a direct variation. So for here, we can say that x vary directly as y. Okay, if x vary directly as y, it is written as x is proportional to y. So that is the name for this sign, the proportionality sign. So if x vary directly as y, it is written as x is proportional to y. In the problems that we will be solving under variations, we are going to work with the equal to sign. So, in order to replace the proportionality sign, this sign here, by an equal to sign, we introduce a constant of proportionality. So, from here we can see that x is proportional to y. So we are going to introduce a constant of proportionality, and that will help us to replace this proportionality sign with an equal to sign. So if x varies directly as y, it is written as x is proportional to y. Now if we multiply y by a constant of proportionality, we can replace this proportionality sign with an equal to sign. So here k is the constant of proportionality. So if x is proportional to y, then x is equal to ky, where k is the constant of proportionality. Now with this expression, we can solve the problems or the questions that we'll be considering under variations. So take note of this. if x is directly proportional to y, or if x varies directly as y, it's written as x is proportional to y. And in order to replace the proportionality sign with an equal to sign, we introduce a constant of proportionality. So here we are going to multiply y, which is on the right hand side, by k, where k is the constant of proportionality. So for here, x is equal to ky, where k is the constant of proportionality. Take note of this expression. We are going to use it a lot in our studies on variations. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you've studied about direct variations in this video to solve questions. In the previous video, we considered direct variation. In this video, we are going to solve a question on direct variation. So let's consider the question for this video. If y varies directly as x and y is equal to 9 when x is equal to 3, find the value of y when x is equal to 4. So here you are being told that y varies directly as x, and you have been given the values y is equal to 9 when x is equal to 3, and we are supposed to find the value of y when x is equal to 4. Okay, so we learned in the previous video that if x varies directly as y, it is written as x is proportional to y. So if x varies directly as y, it's written as x is proportional to y. Here the question says that y varies directly as x. So it's going to be written as y is proportional to x. So you can see the difference from here. This is x varies directly as y, and this is y varies directly as x. Okay, so y varies directly as x. We also learned in the previous video that in order to change this proportionality sign into an equal to sign, we introduce the constant of proportionality. So we are going to multiply x here, which is on the right hand side, by a constant of proportionality. Here I'm choosing k as the constant of proportionality. So y is equal to kx. So as soon as you multiply x by the constant of proportionality, you can change this proportionality sign into an equal to sign. So we have y is equal to kx, where k is the constant of proportionality. So now this is the expression we are going to work with, y is equal to kx. The question says that we should find the value of y when x is equal to 4. In order to do that, we need to find the value of the constant of proportionality. To help us find the value of k, we have been given y is equal to 9 when x is equal to 3. So that is what we are going to use. When x is equal to 3, y is equal to 9. So you substitute these values into the expression that we have here. The expression is y is equal to kx. So if x is equal to 3 when y is equal to 9, then 9. So here y is 9 is now 9. So 9 is equal to k times x, which is 3. So 9 is equal to k times 3. And this will give us 3k is equal to 9. From linear equations, we know that we are going to divide the left hand side by 3 and the right hand side by 3. And k will give us 3. So we now have the value of k to be 3. But we know that our expression is y is equal to kx. And we have just found out that k is equal to 3. So we have y is equal to 3x. Now we can find the value of y when x is equal to 4, because that is what the question told us to find. The question said we should find y when x is equal to 4. We now know that k is 3, so y is equal to 3x. So if x is equal to 4, then y is equal to 3 times 4, and this will give us 12. So we can say that when x is equal to 4, y is equal to 12. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on direct variations. In the previous video, we solved a question on direct variation. In this video, we are going to solve another question on direct variation. The question for this video is: A varies directly as b squared, and a is equal to 54 when b is equal to 6. Find the value of a when b is equal to 5. So we are being told that a varies directly as b squared. What that means is that a is proportional to b squared. And in order to replace this proportionality sign with an equal to sign, we are going to introduce the constant of proportionality. Here I'm using k. Remember, you can use any letter for the constant of proportionality. So if k is the constant of proportionality, then a is equal to kb squared, where k is the constant of proportionality. Now, as soon as you are done writing this expression, you will see that the question is going to give you two values that will help you to find the constant of proportionality. So here we have been given a as 54 and b as 6. So when a is 54, b is equal to 6. So we are going to replace this a here with 54 and we replace b with 6. When you do that, you are going to have 54 is equal to k times 6 squared. And this will give us 36k is equal to 54. We divide the left hand side by 36 and the right hand side by 36, and k is equal to 3 divided by 2. So the constant of proportionality is 3 divided by 2. The expression we had was a is equal to kb squared, and we have just found out that k is 3 divided by 2. So we can say that a is equal to 3 divided by 2b squared. Okay, the question says that we should find the value of a when b is equal to 5. We should find the value of a when b is equal to 5. So when b is equal to 5, a will be equal to 3 divided by 2 times b is now 5, so 5 squared. And this will give us 75 divided by 2. So we can say that when a is 75 divided by 2 when b is equal to 5. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on direct variations. In the previous video, we solved a question on direct variation. In this video, we are going to solve another question on direct variation. The question for this video is: if y varies directly as the square root of x and y is equal to 0.4 when x is equal to 4, find y when x is equal to 100. So in this question, we are being told that y varies directly as the square root of x. This means that y is proportional to the square root of x. In order to replace this proportionality sign with an equal to sign, we introduce the constant of proportionality. The constant of proportionality I'm using here is k. So k is the constant of proportionality. So I'm going to multiply the square root of x by k. Then I will change the proportionality sign to an equal to sign. So y is equal to k times square root of x, which is the same as k square root of x. So this is the expression that we are going to use to solve this question. We are being told that when y is equal to 0.4, x is equal to 4. That means that we can replace this y here with 0.4 and replace this x here with 4 so that we'll be able to find k. So y is 0.4 and x is 4. This means that 0.4 is equal to k times square root of 4, since y is 0.4 and x is 4. Square root of 4 will give us 2. So we have k times 2, which is 2k, is equal to 0.4. From linear equations, we learned that we divide the left-hand side by 2 and the right-hand side by 2. And when you do that, you have k to be 0.2. Remember, the expression was y is equal to k square root of x. And we have found that k is equal to 0.2. So we can say that y is equal to 0.2 square root of x. The question said we should find the value of y when x is equal to 100. So when x is equal to 100, what is the value of y? We have just found out that the expression that we are going to use is y is equal to 0.2 square root of x. So we can replace this x here with 100 since x is 100 in this case. So we have y is equal to 0.2 times square root of 100. And this will give us 2. So from here, we can say that when x is equal to 100, y is equal to 2. Or x is equal to 100 when y is equal to 2. Thank you for watching this video. Subscribe to this channel for more videos. So far, we've considered direct variations and we've solved some questions on direct variation. We are going to consider indirect variation in the next video. So see you in the next video and let's learn more about indirect variation. In the previous videos, we have considered direct variation and we've solved some questions on direct variation. In this video, we are going to consider indirect variation. Indirect variation is also referred to as inverse variation. So we are going to consider inverse variation or indirect variation. Now, what is an inverse or indirect variation? If two quantities x and y are related such that I, an increase in x results in a decrease in y, a decrease in x results in an increase in y, then x is said to vary inversely or indirectly as y. So if there is a connection between two quantities x and y such that as x increases, y decreases, and as x decreases, y increases, then x is said to vary inversely or indirectly as y. Let's consider these examples. Let's say that this is a table and we have this spring on the table. We have a load of 45 grams on the spring. Now, the load on the spring is increased from 45 grams to 50 grams. It's the same spring. In the third instant, the load on the spring is increased from 50 grams to 55 grams. Then finally, the load is increased from 55 grams to 60 grams. Now you can see clearly from here that as we increase the load, the length of the spring decreases. So let's say that we measure the length of the spring in the first case and we have 10 centimeters. In the second case, we measure the length of the spring and we have 8 centimeters. In the third case, we measure the length of the spring and we had 6 centimeters. And finally, the length of the spring is 3 centimeters. So if we draw this simple two-column table with the load on one side and the length of the spring on one side, we can see clearly from this table that as the load on the spring increases, the length of the spring reduces or decreases. So as the load increases from 45 grams to 50 grams, the length of the spring decreases from 10 centimeters to 8 centimeters. In the same way, as the load increases from 50 grams to 55 grams, the length of the spring decreases from 8 centimeters to 6 centimeters. So as the load increases, the length of the spring decreases. If we look at it in the opposite direction, we can also see that as the load decreases, That is, as the load decreases from 60 grams to 55 grams, the length of the spring increases from 3 centimeters to 6 centimeters. So you can see clearly from this table and this illustration that as the load on the spring increases, the length of the spring decreases. Or as the load on the spring decreases, the length of the spring increases. This type of relationship is what we refer to as inverse or indirect variation. As one quantity increases, the other decreases, and as one quantity decreases, the other increases. This is inverse or indirect variation. If x is inversely proportional to y, it is written as x, then we bring the proportionality sign 1 divided by y. So if x is inversely proportional to y, it is written as x, you write the proportionality sign 1 divided by y. We learned from the videos on direct variation that if you are going to solve questions with this expression, we will have to change the proportionality sign to an equal to sign. And to help us do that, we have to introduce a constant of proportionality. So if k is the constant of proportionality, then x is equal to k times 1 divided by y. So we change the proportionality sign to an equal to sign. Then we multiply the expression we have on the right hand side by k. So we have x is equal to k times 1 divided by y, where k is the constant of proportionality. And if we simplify this, we will have x is equal to k divided by y. So if x is inversely or indirectly proportional to y, then x is equal to k divided by y, where k is the constant of proportionality. Now, this expression here is very, very important. Take note of it because we are going to use it to solve a lot of questions. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve a question on indirect or inverse variation. In the previous video, we considered inverse or indirect variation. In this video, we are going to solve a question on inverse or indirect variation. The question for this video is, if y is inversely proportional to x and y is equal to 5.2 when x is equal to 0.5, find the equation connecting x and y. Okay, so we write our solution. We are being told in the question that y is inversely proportional to x, which means that y is proportional to 1 divided by x. In the previous video, we learned that if x is inversely proportional to y, it's written as x, then you write your proportionality sign 1 divided by y. Here, we are being told in the question that y is inversely proportional to x. So y will be on the left hand side, then we have our proportionality sign 1 divided by x because y is inversely proportional to x. Okay, to solve this, we need to replace this proportionality sign with an equal to sign, and in order to do that, we introduce a constant of proportionality. So we are going to have y is equal to k times 1 divided by x, where k is the constant of proportionality. So as soon as we multiply 1 divided by x by k, we can change the proportionality sign to an equal to sign. K times 1 divided by x is the same as k divided by x. So we have y is equal to k divided by x. Now the question told us that when x is equal to 0.5, y is equal to 5.2. So when y is equal to 5.2, x is equal to 0.5. That means that we can replace y with 5.2 and replace x with 0.5, and that will help us to find k. If you do that, you are going to have 5.2 is equal to k divided by 0.5. Now I'll multiply the left hand side by 0.5. I'll multiply the right hand side by 0.5, and this will help me to cancel out the fractions. We learned how to do this when we are learning how to solve linear equations. So 0.5 will cancel 0.5, which means that k is going to be equal to 5.2 times 0.5, which is equal to 2.6. Remember, the expression we had at the beginning was y is equal to k divided by x, and we have found out that k is 2.6. So we can say that y is equal to 2.6 divided by x. The question said we should find an equation connecting x and y, and this is the equation. Y is equal to 2.6 divided by x. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on inverse or indirect variation. In the previous video, we solved a question on indirect or inverse variation. In this video, we are going to solve another question on indirect or inverse variation. The question for this video is, given that y is inversely proportional to x squared, and y is equal to 10 when x is equal to 6. Find the value of y when x is equal to 4. So we are being told that y is inversely proportional to x squared. That means that y is proportional to 1 divided by x squared. Now, we know that in order to work with this expression, we need to change the proportionality sign to an equal to sign. And in order to do that, we introduce a constant of proportionality. So if k is the constant of proportionality, then we can say that y is equal to k times 1 divided by x squared. And this will give us y is equal to k divided by x squared. We can now work with this expression. The question told us that y is equal to 10 when x is equal to 6. That means that we can replace y with 10 and x with 6 so that we will be able to find k. And if we do that, we will have 10 is equal to k divided by 6 squared, since y is 10 and x is 6. This will give us 10 is equal to k divided by 36. So I'll multiply the left hand side by 36 and multiply the right hand side by 36 so that I'll be able to cancel 36 out. So k will give us 36 times 10, which is 360. Remember, the expression was y is equal to k divided by x squared, and we have found out that k is 360. So you have y is equal to 360 divided by x squared. The question said we should find y when x is equal to 4. Now we have this expression, y is equal to 360 divided by x squared. So when x is equal to 4, then y is equal to 360 divided by 4 squared, since x is now 4. And this will give us 22.5 or 22.5. So we can say that when x is equal to 4, y is equal to 22.5. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on inverse or indirect variation. In the previous video, we solved a question on inverse or indirect variation. In this video, we are going to solve another question on inverse or indirect variation. The question for this video is, r varies inversely as the cube of x. If r is equal to 9 when x is equal to 3, find x when r is equal to 243 divided by 64. So we are being told that r varies inversely as the cube of x. The cube of x, or s cube, is written as x raised to the power 3. So this is the cube of x, or s cube. So if r varies inversely as the cube of x, it's going to be written as r is proportional to 1 divided by s to the power 3, or s cube, or the cube of x. So r varies inversely as the cube of x is written as r is proportional to 1 divided by s cube. Now we know that in order to work with this expression, we need to change this proportionality sign to an equal to sign. And to do that, we have to introduce a constant of proportionality. So if k is the constant of proportionality, then r is equal to k times 1 divided by s to the power 3, or s cube. And this will give us r is equal to k divided by x to the power 3. Okay, the question told us that when r is 9, x is 3. So we can use r equal to 9 and s equal to 3 to find the value of k. So when r is 9, x is equal to 3. That means that 9, which is the same as r, 9 which is equal to r, is equal to k divided by x, which is equal to 3. So 3 exponent 3. And this will give us 9 is equal to k divided by 27. So you multiply the left hand side by 27 and the right hand side by 27. 27 and 27 will cancel out, so k is equal to 27 times 9, and k will give us 243. Remember, the expression we had at the beginning was r is equal to k divided by s cube. So if k is 243, we can say that r is equal to 243 divided by s cube. The question said we should find the value of x when r is equal to 243 divided by 64. That means that we can replace r with 243 divided by 64. So we are going to have 243 divided by 64 is equal to 243 divided by x to the power 3. If you look at this equation very well, you can see that the left hand side is a fraction and the right hand side is also a fraction. The numerator on the left hand side is the same as the numerator on the right hand side. If you have that, you can equate the denominators since the two fractions are equal. So since the numerator here is 243 and the numerator here is also 243, we can equate the two denominators. So we have 64 is equal to x to the power 3, or x to the power 3 is equal to 64. Now, in the videos on change of subjects, we learned that here if you want to find x or make x the subject, you need to find the cube root of x. You need to find the cube root of x to the power 3. And whatever you do to the left hand side, you do the same thing to the right hand side. So if you find the cube root of x to the power 3, you need to find the cube root of 64 also. So we find the cube root of x to the power 3 and we find the cube root of 64. If you find the cube root of x to the power 3, you are going to have x. And cube root of 64 will give us 4. So x is equal to 4. So we can say that x is equal to 4 when r is equal to, so x is equal to 4 when r is equal to 243, okay, so this is r. So from here we can say that x is equal to 64 when r is equal to 243 divided by 64. Thank you for watching this video. Subscribe to this channel for more videos. So far, we have considered inverse and direct variations. In the next video, we are going to consider joint variation. We have considered direct and indirect or inverse variation in the previous videos. In this video, we are going to consider joint variation. Joint variation. In the videos on direct and inverse variations, we learned that if x varies directly as y, is written as x is proportional to y. And if A varies inversely as B, it's written as A is proportional to 1 divided by B. We can see that in each of these cases, there are only two quantities involved. In the first case, we have X and Y. And in the second case, we have A and B. But in most cases, quantities depend on two or more other quantities. So we can see that for here we have X and Y, that is only two quantities. And here we have A and B, only two quantities. But in most cases, quantities depend on two or more other quantities. For example, let's consider the formula for the area of a rectangle. From the videos on mensuration, we learned that the area of a rectangle is equal to length times breadth. Looking at this formula carefully, we can see that the area of a rectangle depends on both the length and the breadth. So the area A depends on the length L and the breadth B. Another example is this. The density of a material is equal to the mass of the material divided by its volume. So for density, it depends on the mass and the volume of the material. So density depends on two other quantities, mass and volume. If you have such a relationship where a quantity depends on two or more other quantities, that type of relationship is referred to as a joint variation. So in fact, joint variations combine two or more other variations. So for joint variations, it combines two or more other variations. We are going to consider three cases of such combination. The first one is when you have a combination of direct variations. An example is X varies directly as Y and Z. So for joint variation, you can have a combination of direct variation. So here we have X varies directly as Y and Z. We can break this statement into two parts. The first part is X varies directly as Y, and the second part is X varies directly as Z. So X varies directly as Y, and at the same time, it varies directly as Z. From the videos on direct variations, we learned that if X varies directly as Y, it's written as X is proportional to Y. And if X varies directly as Z, it's written as X is proportional to Z. Now, because this is a joint variation, we have to join these two variations together. Now, how do we join them together? We have X here, we have X here, so you write one of them. We have the proportionality sign here, we have the proportionality sign here, you write one of them. Then we have Y here and Z here. You join these two, so you are going to have Y times Z. And this will give us X is proportional to YZ. We know that we can't work with this proportionality sign, so we need to change it into an equal to sign. And to do that, we introduce a constant of proportionality. So if K is the constant of proportionality, then X is equal to K times YZ, and X is equal to KYZ. Now you can see from here that X is dependent on Y and Z. So one quantity is dependent on two other quantities. This is an example of a joint variation. Let's consider another case of a combination. You can also have a combination of direct or inverse variations. The first one we considered, we had a combination of direct variation. In this second case, you can have a combination of indirect or inverse variation. So for example, X varies inversely as Y and inversely as Z. What this statement means is that 1. X varies inversely as Y, and 2. X varies inversely as Z. From the videos on inverse or indirect variations, we learned that if X varies inversely as Y, it's written as X is proportional to 1 divided by Y. If X varies inversely as Z, it's written as X is proportional to 1 divided by Z. Now, since this is a joint variation, we are going to join these two variations together. So we have x here, you write one of them. We have the proportional sign here, we have the proportionality sign here, we have the proportionality sign here, you write one of them. Then we join these two. So 1 divided by y times 1 divided by z. And this will give us x is proportional to 1 divided by yz. We are going to introduce the constant of proportionality. That means that we can change this proportional sign to an equal to sign. So if k is the constant of proportionality, then x is equal to k times 1 divided by yz. And this will give us x is equal to k divided by yz. Now, since k is a constant, we can see that x is dependent on both y and z. This is another case of a joint variation. We are going to consider the third type of combination. That is, you can have a combination of a direct variation and an inverse variation. So in the two examples that we considered, we had a combination of direct variation and a combination of inverse variation. Here, in the same variation, you have a direct variation and an inverse variation. An example is this: x varies directly as y and inversely as z. So in the first case, x varies directly as y, and in the second case, x varies inversely as z. Now, how do we write this? We learned that if x varies directly as y, it's written as x is proportional to y. If x varies inversely as z, is written as x is proportional to 1 divided by z. So if we are combining these two, we are going to have x is proportional to y times 1 divided by z. Since we have x here, you write only one of them. You write one of the proportionality signs, then you combine these two. So we have y times 1 divided by z. And this will give us x is proportional to y divided by z. We are going to change this proportionality sign to an equal to sign. So we are going to have x is equal to k times y divided by z, since k is the constant of proportionality. So we have x is equal to k times y divided by z. And this is going to give us x is equal to ky divided by z. Now, we know that k will be a constant, so we can say that x is dependent on both y and z. This is another case of a joint variation. So we've considered three cases: when there is a combination of direct variation, when there is a combination of inverse or indirect variation, and when there is a combination of both direct and inverse variation. So when there's a combination of direct variation, that is x varies directly as y and z, x is equal to kyz when k is the constant of proportionality. When x varies inversely as y and inversely as z, it's written as x is equal to k divided by yz, where k is the constant of proportionality. And when x varies directly as y and inversely as z, is written as x is equal to ky divided by z, where k is the constant of proportionality. Take note of these expressions. We are going to use them to solve questions. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to use what you've learned in this video to solve questions on joint variation. In the previous video, we considered joint variation. In this video, we are going to solve a question on joint variation. The question for this video is: x varies directly as y and inversely as the square of z. Given that x is equal to 4 and y is equal to 1 when z is equal to 2, find the equation connecting x, y, and z. So this is a combination of a direct variation and an inverse variation. The question says that x varies directly as y, so x is proportional to y. And at the same time, x varies inversely as the square of z, so x is proportional to 1 divided by z squared. We have to combine these two variations since this is a joint variation. So we are going to have x is proportional to y times 1 divided by z squared. So we have x here, you write one of them. We have the proportionality sign here. We also have the proportionality sign here. You write one of them. Then you combine y and 1 divided by z squared. That will give us y times 1 divided by z squared. And this will give us x is proportional to y divided by z squared. We know that we have to replace this proportionality sign with an equal to sign. And to do that, we introduce a constant of proportionality. So if k is the constant of proportionality, then x is equal to k times y divided by z squared, and x is equal to ky divided by z squared. Remember, we are looking for an equation connecting x, y, and z. That means that we need to find the value of k. To help us do that, we have been given x is equal to 4, y is equal to 1, when z is equal to 2. So we have x is equal to ky divided by z squared, and we know that when z is equal to 2, x is equal to 4, and y is equal to 1. That means that we can replace x with 4, y with 1, and z with 2 in order to find k. If you do that, we are going to have 4 is equal to k times 1 divided by 2 squared. This will give us 4 is equal to k divided by 4. We solve this linear equation, so you multiply the left hand side by 4, the right hand side by 4, and k will give us 16 because 4 and 4 will cancel, so k will give us 4 times 4, which is 16. So we have now found the value of k. We can replace k with 16, and if you do that, we are going to have x is equal to 16y divided by z squared. So this is the equation connecting x, y, and z. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on joint variation. In the previous video, we solved a question on joint variation. In this video, we are going to solve another question on joint variation. The question for this video is: three quantities P, Q, and R are connected such that P varies directly as R and inversely as the square root of Q. P is equal to 6 when R is equal to 12 and Q is equal to 25. Find the value of Q when P is equal to 30 and R is equal to 9. So we have been given three quantities, and these three quantities are in a joint variation. And the connection is such that P varies directly as R, and the same P varies inversely as the square root of Q. So for the first case, we have P varies directly as R, so P is proportional to R, and P varies inversely as the square root of Q, so it means that P is proportional to 1 divided by the square root of Q. Since this is a joint variation, we have to join these two, and if you join them, you have P is proportional to R divided by the square root of Q. Now we need to replace this proportionality sign with an equal to sign, so we introduce a constant of proportionality. So if k is the constant of proportionality, then P is equal to k times R divided by square root of Q, which will give us KR divided by the square root of Q. So this is the expression connecting P, Q, and R, but we need to find the value of K. Okay, so we have P is equal to KR divided by the square root of Q. The question told us that P is equal to 6 when R is equal to 12 and Q is equal to 25. That means that we can replace P with 6, R with 12, and Q with 25 in order to find the value of K. If you do that, you have 6 is equal to K times 12 divided by the square root of 25. And this will give us 6 is equal to 12k divided by 5, since square root of 25 is 5. To find the value of k, I'll multiply the left hand side by 5, the right hand side by 5, and this will give us 12k is equal to 30. We divide both sides by 12 and k is equal to 2.5. So if k is equal to 2.5, it means that we can replace this k here with 2.5. So p is equal to 2.5r divided by the square root of k. We now have the equation connecting p, r, and k. The question said we should find the value of k when p is 30 and r is 9. But we have found out that p is equal to 2.5r divided by the square root of k. This means that if we replace p with 30 and r with 9, we can find the value of k. When we do that, we will have 30 is equal to 2.5 times 9 divided by the square root of k. And this will give us 30 is equal to 2.5 times 9 will give us 22.5. So 22.5 divided by the square root of k. To help us find k, I'll multiply the left hand side by square root of k and the right hand side by square root of k. If we do that, we can see that square root of k and square root of k here will cancel. So we are going to have square root of k times 30. From the videos on sets, we learned that this can be written as 30 square root of k, and this is equal to 22.5. So I will divide the left hand side here by 30 and the right hand side by 30. When we do that, we will have 30 here. 30 will cancel 30. So 30 will cancel 30. That means that square root of k will be equal to 22.5 divided by 30, which is 3 divided by 4. So we have square root of k is equal to 3 divided by 4. We need to find k or make k the subject. From the videos on change of subjects, we learned that when you get to this level, in order to find k, you square both sides. In order to find k, you square both sides. So we find the square of square root of k and you find the square of 3 divided by 4, because whatever you do to the left hand side, you do the same thing to the right hand side. If you square square root of k, you are going to have k, and the square of 3 divided by 4 is 9 divided by 16. So k is equal to 9 divided by 16. So from here we can say that k is equal to 9 divided by 16 when p is equal to 30 and r is equal to 9. Thank you for watching this video. Subscribe to this channel for more videos by clicking on the subscribe button that you see below. In the next video, we are going to solve another question on joint variation. In the previous video, we solved a question on joint variation. In this video, we are going to solve another question on joint variation. The question for this video is: the heat H produced by an electric current varies directly as the square of the applied voltage V and inversely as the resistance R of the wire. If a voltage of 540 volts is applied to a wire of resistance 40 ohms, the heat produced is 1458 joules. Find A, the expression between H, V, and R. B, the resistance that will produce 588 joules of heat when the applied voltage is 420 volts. We will solve the first part of the question in this video, then we will solve the second part in the next video. The question said that the heat H produced by an electric current varies directly as the square of the applied voltage and inversely as the resistance R of the wire. So the heat H varies directly as the square of the applied voltage V. That means that H varies directly as V squared. And at the same time, that heat H varies inversely as the resistance R of the wire. So H varies inversely as R. So for the first part, H varies directly as the square of V. So H is directly proportional to V squared. And for the second part, H varies inversely as R. So H is proportional to 1 divided by R. Since this is a joint variation, we are going to combine these two variations. So you have H is proportional to V squared divided by R. And if we introduce the constant of proportionality, which in this case we are going to call K, H is equal to K times V squared divided by R, and H is equal to KV squared divided by R. The first part of the question said we should find an equation or expression connecting H, V, and R. So that means that we need to find the value of K. How do we do that? We were told in the question that a voltage of 540 volts applied to a wire of resistance 40 ohms produce 1458 joules of heat. That means that when the voltage is 540 and the resistance is 40, the heat produces 1458, meaning that if V is equal to 540 and R is equal to 40, then H is equal to 1458. The expression we have is H is equal to KV squared divided by R. So it means that we can replace H with 1458, replace V with 450, and we replace R with 40. That will help us to find the value of K. So we have H, which is 1458, is equal to K times V is 540, so 540 squared divided by R, which is 40. So we are going to simplify this. 540 squared will give us 291600. So we have 1458 is equal to 291600K divided by 40. When we break this down further, you are going to have 7290K is equal to 1458. We divide both sides by 7290. So we divide the left hand side by 7290. We divide the right hand side by 7290. And K is equal to 0.2. So you see that immediately you get to this level, the rest is solving linear equation. So if you solve this linear equation, you are going to have K as 0.2. Now remember, this is the expression. H is equal to KV squared divided by R. So if K is 0.2, then we can say that H is equal to 0.2 V squared divided by R. This is the first part of the question. We have been able to find an expression connecting H, V, and R. We are going to solve the second part of the question in the next video. So see you in the next video and let's continue solving this question. Welcome back. We started solving this question in the previous video and we considered the first part, which is the expression between H, V, and R. In this video, we are going to solve the second part, the resistance that will produce 588 joules of heat when the voltage is 240 volts. So we are looking for the resistance that will produce 588 joules of heat when the voltage is 420 volts. So if H is equal to 588 and V is equal to 420, we are looking for R, which is the resistance. In the previous video, we found out that the expression connecting H, V, and R is H is equal to 0.2 V squared divided by R. So if H is 588 and V is 420, we can substitute them into this expression to find the value of R. So you have 588 is equal to 0.2 times 420 squared divided by r. This will give us 588 is equal to 35280 divided by r. I'll multiply the left hand side by r and the right hand side by r. Now you have r and r cancelling out. This is going to give us 588r is equal to 35280. So we divide both sides by 588 from linear equations, and r will give us 60. So you see, as soon as you get to this level, solving the remaining part is linear equation, and we've solved a lot of linear equations. So when you solve this linear equation, r will give us 60. The unit of r is ohms, so it means that the resistance is 60 ohms. So from here we can say that a 60 ohm resistance will produce 588 joules of heat when the applied voltage is 420 volts. Thank you for watching this video. Subscribe to this channel for more videos by clicking on the subscribe button that you see. So far, we have considered direct, indirect or inverse, and joint variation. In the next video, we are going to consider partial variation. In the previous video, we solved a question on joint variation. In this video, we are going to consider partial variation. So, partial variation. To help us understand partial variation, let's consider this example. For most workers, this is how their salary is being calculated. So their monthly salary is equal to a fixed amount plus allowances or bonuses. An example is this. Kofi works as a salesperson in a company. His monthly salary is 500 Ghana cedis plus 2% of his total sales at the end of the month. So for Kofi, his monthly salary is determined by two things. 1. 500 Ghana cedis, which is a fixed amount, plus his allowances or bonuses, which is 2% of his total sales at the end of the month. So at the end of each month, Kofi is paid 500 Ghana cedis, and in addition to that, he is being given 2% of his total sales at the end of the month as his allowance or bonus. So let's say that in the month of May, Kofi made a total sales of 10,000 Ghana cedis. So Kofi's salary is going to be 500 Ghana cedis, which is the fixed amount, plus 2% of 10,000 Ghana cedis, which was his total sales at the end of the month. 2% of 10,000 Ghana cedis is equal to 2 divided by 100 times 10,000 Ghana cedis, and that will give us 200 Ghana cedis. So if we add the 200 Ghana cedis to the 500 Ghana cedis, Kofi is going to receive a salary of 700 Ghana cedis. Let's say that in the month of June, Kofi made a total sales of 7,000 Ghana cedis. So his salary is going to be 500 Ghana cedis plus 2% of his total sales, which is 7,000 Ghana cedis. 2% of 7,000 Ghana cedis will give us 140 Ghana cedis. And you add that to 500 Ghana cedis, you are going to have 640 Ghana cedis. So we can see clearly from here that Kofi's salary depends on two things. It depends on 1, a fixed amount, which is 500 Ghana cedis, and an allowance that keeps on changing. In the month of May, Kofi had an allowance of 200 Ghana cedis. In the month of June, Kofi had an allowance of 140 Ghana cedis, because his allowance is determined by his total sales at the end of the month, and definitely his total sales at the end of the month will keep on changing. So Kofi's salary structure is like this. It's determined by a fixed amount, that is 500 Ghana cedis. That is a constant. So you can see from here that the 500 Ghana cedis doesn't change, but his allowance varies or changes. So Kofi's salary depends on a constant, which is 500 Ghana cedis, an allowance that keeps on changing. This type of relationship is what we refer to as partial variation. Kofi's salary depends on two things. It varies in parts. The first part is a constant, and the other part keeps on changing. So the first part is a constant that doesn't change, and the other part keeps on changing. That is, his allowance keeps on changing. If you have such a relationship where one part is a constant and the other part keeps on changing, that type of relationship is referred to as a partial variation. So for here, Kofi's salary depends on one, the constant, two, the allowance that keeps on changing. So here the allowance varies, it changes. This variation here, that is the variation in the allowance, can either be a direct variation or an inverse variation. So we are going to consider both cases. The first case is when you have a constant. So in this case, we have the constant, and the part that keeps on changing is actually a direct variation. So the part that keeps on changing is a direct variation. Now let's consider this statement. Y varies partly as a constant C and partly varies directly as x. What this means is that y is in two parts. The first part, which is a constant, and that constant is c. And the second part, which is a direct variation. So for the second part, we can say that y varies directly as x. For the first part, y varies as the constant c. For the second part, y varies directly as x. So that is a direct variation. From direct variations, we learned that if y varies directly as x, it is written as y is proportional to x. And if we introduce the constant of proportionality, then y is equal to ks. What this means is that the first part of y is c, and the second part is ks, because y varies directly as x, and we introduce the constant of proportionality k, so y is equal to k. So we can say that, I'm going to clean the pencils here. So we can say that the first part of this variation is c, and the second part is ks. So the constant is c, and the direct variation part is ks. Now we are going to add c to ks, because previously we saw that Kofi's salary is equal to the constant plus the allowance. So in this case, the direct variation is giving us the allowance. So y is equal to the constant, which is c, plus the variation part, which is ks, where k is the constant of proportionality. So if y varies partly as the constant c and varies partly directly as x, what that means is that y is equal to c plus ks, where k is the constant of proportionality. This is when the variation part is a direct variation. We are going to consider when the variation part is an inverse or indirect variation. So for here, y varies partly as a constant p and partly varies inversely as x. So in this case also, the first part is a direct variation. Sorry, the first part is a constant. So for the first part, y varies as the constant p, and that constant is p, as we have here. Now, the second part is an inverse or indirect variation. So y varies inversely as x. From the videos on inverse variation, we learned that if y varies inversely as x, it's written as y is proportional to 1 divided by x. And if we introduce the constant of proportionality, then y is equal to kx. This means that the second part is, y is equal to k divided by x. This means that the second part of y is k divided by x. The first part of y is p. Okay, so the first part is p and the second part is k divided by x. So the inverse variation part is k divided by x, and the constant part is p. What this means is that y is equal to the first part, which is p, plus the second part, which is k divided by x, where k is the constant of proportionality. So if y varies partly as a constant p and partly varies inversely as x, then the first part of the constant p plus the inverse variation part, which is k divided by x. So y is equal to p plus k divided by x, where k is the constant of proportionality. So we are going to have two constants here. The first part of the variation, which is p, plus the constant of proportionality that we have introduced, which is k. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to use what we've studied about partial variation in this video to solve questions. In the previous video, we considered partial variation. In this video, we are going to solve a question on partial variation. So let's look at the question for this video. Y varies partly as a constant and partly varies as x. Given that y is equal to 40 when x is equal to 1 and y is equal to 13 when x is equal to 2, find the value of y when x is equal to 3. So we can see clearly from here that our variation is in two parts. So this is a partial variation. The first part of our variation is a constant, and the second part we are being told that y varies as x. So for the first part we have a constant. So let's say that we are going to represent the constant with p. So let p equal to the constant. That means that the first part of the variation is p, since the first part is a constant. So we have the first part of the variation, which is p. For the second part, we are being told that y varies as x, or y varies partly as x. So for the second part, y varies as x. Now, the question did not tell us whether the variation is direct or inverse. If the question does not tell you whether the variation is direct or inverse, it means that it's direct. So if you are being told that y varies as x, is the same as y varies directly as x. So for the second part, we have a direct variation because y varies as x. From the videos on direct variations, we learned that if y varies as x, it's written as y is proportional to x. And if we introduce the constant of proportionality, which is k, we will have y is equal to kx. So for the second part of this variation, y is kx. For the first part, y is p. Okay, so we have the first part, which is p. We have the first part, which is p, and the second part, which is kx. So the first part of the variation is p, and the second part of this variation is kx. That means that y is equal to the first part, which is p, plus the second part, which is kx, where k is the constant of proportionality. So we have two constants here. We have the first constant, which is p, and k, which is the constant of proportionality. Now the question told us that when y is equal to 40, x is equal to 1. So we can replace y with 40 and x with 1. That will give us 40 is equal to p plus k times 1 because x is 1. Now this is going to give us p plus k is equal to 40 since k times 1 or 1 times k is k. The question also told us that when y is equal to 13, x is equal to 2. That means that we can replace y with 13 and x with 2. So if you do that, you are going to have 13 is equal to p plus 2 times k. And that will give us p plus 2k is equal to 13. So we have this here as our first equation or equation 1. And we have this here as our second equation or equation 2. Now we have two linear equations with two variables. So we are going to solve them simultaneously for the value of p and the value of k. We are going to solve the simultaneous equation in the next video. So see you in the next video and let's continue solving this question. Welcome back. In the previous video, we started solving this question and we got to this point where we had the first equation and the second equation. and we are going to solve these two equations simultaneously. So we are going to continue from here in this video. So we have equation 1 as p plus k is equal to 40 and equation 2 as p plus 2k is equal to 13. We are going to use the elimination method. So we have equation 2 minus equation 1. I've explained how to solve simultaneous linear equations in the videos on simultaneous linear equation. So you can watch those videos to have more knowledge about how to solve simultaneous equations. So we have equation 2 minus equation 1 here. This is going to give us p minus p plus 2k minus k is equal to 13 minus 40. And this will give us k is equal to minus 27. So we have the value for k as minus 27. From equation 1, we know that p plus k is equal to 40, but we have found k to be minus 27. So you have p, we can replace k with minus 27. So p minus 27 is equal to 40, and this will give us p is equal to 40 plus 27, and p is equal to 67. So we have k as minus 27 and p as 67. Once again, I've explained how to solve simultaneous linear equations in the videos on solving simultaneous linear equations. So if you watch those videos, you understand how to use both the elimination and substitution method to solve this simultaneous linear equation. At the beginning of the previous video, we saw that the expression for this variation is y is equal to p plus kx, and we have been able to find the value of p as 67 and the value of k as minus 27. So we will replace p with 67 and k with minus 27. This is going to give us y is equal to 67 minus 27x. Now we have an equation connecting y and x. The question said that we should find the value of y when x is equal to 3. We have this equation here as y is equal to 67 minus 27x. So we can replace x with 3. That will help us to find the value of y when x is 3. And if we do that, we are going to have y is equal to 67 minus 27 times x, but x is now 3. So y is equal to 67 minus 27 times 3. This will give us 67 minus 81. 27 times 3 is 81. And 67 minus 81 gives us minus 14. This means that when x is equal to 3, y is equal to minus 14. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on partial variation. In the previous video, we solved a question on partial variation. In this video, we are going to solve another question on partial variation. The question for this video is: the cost per head of catering for students is partly constant and partly inversely proportional to the number of students present in a school. If the cost per head of catering for 10 students is 35 cedis and the cost per head of catering for 15 students is 25 Ghana cedis, find the cost of catering for 40 students. To solve this question, we are going to define the variables that we'll be using in the solution. So you let C represent the cost per head of catering for students, and N represents the number of students. We are being told in the question that the cost per head of catering for students is partly constant and partly inversely proportional to the number of students in the school. So this is a partial variation, and the first part is a constant. We will let K represent that constant. Now, we can deduce from the question that the cost of catering for students, which we have represented by C, is partly constant, and we have represented that constant by Q, and partly inversely proportional to the number of students, which we have represented by N, present in the school. So it means that the first part of C is a constant. So C is partly constant. So the first part is a constant, and that constant is Q. The second part is an inverse variation. So C is inversely proportional to N, which is the number of students in the school. We learned from the videos on inverse variation that if C is inversely proportional to N, it's written as C is proportional to 1 divided by N. And if we introduce the constant of proportionality, which is K, then C is equal to K divided by N. So this means that the first part of C is the constant K, and the second part of C is K divided by N. So the first part of C is K, and the second part of C is K divided by N. So C is equal to the first part, which is K, plus the second part, which is K divided by N, where K is the constant of proportionality. We are being told to find the cost of catering for 40 students. So we need an equation connecting C and N. That means that we need to find the value of Q and K. The question told us that the cost per head of catering for 10 students is 35 Ghana cedis. This means that when the number of students which we have represented with N is 10, then the cost per head is 35 Ghana cedis. Remember, we represented the cost per head with C. So N is equal to 10 when C is equal to 35. Our expression is C is equal to Q plus K divided by N. So we can replace C with 35 and N with 10. This will give us 35 is equal to Q plus K divided by 10. To remove the fractions, I'll multiply through by the LCM here, which is 10. So I'll multiply each term by the LCM. When we are learning linear equations, we learned how to do this. So this will give us 10 times 35 is equal to K times 10 plus K divided by 10 times 10. And when we simplify, we will have 10K plus K is equal to 350. This is the first equation. The question also told us that the cost per head of catering for 15 students is 25 Ghana cedis. What this means is that when the number of students which we have represented with N is 15, then the cost per head which we represented with C is 25. Remember that our expression is C is equal to Q plus K divided by N. So we can replace C with 25 and N with 15. That will give us 25 is equal to Q plus K divided by 15. We will multiply through by 15 to remove the fraction. And that when we do that, we will have 15 times 25 is equal to Q times 15 plus K divided by 15 times 15. If we simplify this, we will have 15Q plus K is equal to 375. This is equation 2. So we have equation 1 as 10Q plus K is equal to 350, and equation 2 as 15Q plus K is equal to 375. We are going to solve these two equations simultaneously for the value of Q and K. We will solve the simultaneous equation in the next video. So see you in the next video, and let's continue solving this question. Welcome back. We started solving this question in the previous video, and we got to this point where we had two equations. The first equation is 10K plus K is equal to 350, and the second one is 15K plus K is equal to 375. And we are going to solve these two equations simultaneously for the value of Q and K, which are the constants. We are going to use the elimination method here. So we have equation 2 minus equation 1. This will give us 15K minus 10K plus k minus k is equal to 375 minus 350. 15 kilo minus 10 kilo will give us 5 kilo. K minus k is 0, and 375 minus 350 will give us 25. We divide both sides by 5 and kilo is equal to 5. So we have found the first constant, which is kilo, and kilo is giving us 5. We need to find the second one. From equation 1, we know that 10 kilo plus k is equal to 350. We have just found out that kilo is 5. This means that we can replace kilo here with 5. When we do that, we will have 10 times 5 plus k is equal to 350. 10 times 5 is 50. So you will have 50 plus k is equal to 350. If we group like terms, you have k is equal to 350 minus 50, and so k is equal to 300. So you have been able to find the value of the two constants. K is 5 and k is 300. In the previous video, we saw that the expression for this variation is c is equal to k plus k divided by n. We have found k as 5 and k as 300. So we can replace k with 5 and k with 300. When we do that, we will have c is equal to 5 plus 300 divided by n. We now have an equation connecting c and n. The question said we need to find the cost of catering for 40 students. The cost of catering for 40 students. So for here, n, which is the number of students, is 40. We know that c is equal to 5 plus 300 divided by n. So we can replace n with 40. If we replace n with 40, c will give us 5 plus 300 divided by 40. And if we simplify this, we will have c as 12.5. So we can say that the cost per head of catering for 40 students is 12 Ghana cedis, 50 pesos. Now remember that when we are defining the variables in the previous video, we said that c is the cost per head of catering for students. So this c that we found here, which is 12.5, is the cost per head of catering for 40 students. That means that for 40 students, each one of them will pay 12 Ghana cedis, 50 pesos. But the question did not ask us for the cost per head of catering for 40 students. It asked for the cost of catering for all the 40 students. So if each student will pay 12 Ghana cedis, 50 pesos, and there are 40 students, then we can say that the cost of catering for the 40 students is equal to 40 times 12 Ghana cedis, 50 pesos, because each student will pay 12 Ghana cedis, 50 pesos, and there are 40 students. So the cost of catering for 40 students is equal to 40 times 12 Ghana cedis, 50 pesos. 12.5 times 40 will give us 500. So that means that the cost of catering for 40 students is 500 Ghana cedis. Thank you for watching this video. Subscribe to this channel for more videos by clicking on the subscribe button that you see. In the next video, we are going to solve another question on partial variation. In the previous video, we solved a question on partial variation. In this video, we are going to solve another question. The question for this video is: the pressure of a liquid in a tube is partly constant and partly varies as the square root of the cross-sectional area. When the pressure is at 990 millimeters, the cross-sectional area is 2.25 millimeters. And when the pressure is at 842 millimeters, the cross-sectional area is 6.25 millimeters. Find the cross-sectional area when the pressure is at 770 millimeters. Correct your answer to 2 decimal places. So this is an example of a partial variation. The pressure depends on two things. it depends on a constant and on the square root of the cross-sectional area, or on the cross-sectional area. We are being told that it's partly constant, the pressure is partly constant, and partly varies partly as the square root of the cross-sectional area. To solve this question, we need to define the variables that we'll be using in our solution. So we are going to let P represent the pressure of the liquid, and we will let A represent the cross-sectional area. The question told us that the pressure in the tube is partly constant. So we are going to represent that constant with C. So C is equal to the constant. Now from the question, we know that the pressure of the liquid, which we have represented by P, is partly constant, and we are representing that constant by C, and partly varies as the square root of the cross-sectional area, which we have represented by A. So we can see from here that the pressure is in two parts. The first part is a constant. So the first part is the constant, and we have represented that constant by C. The second part is a direct variation, because we are being told that the pressure, which is P, varies directly as the square root of the cross-sectional area. That means that P varies directly as the square root of the cross-sectional area. So P is directly proportional to the square root of the cross-sectional area, which is A. If we introduce the constant of proportionality, then P is equal to K root A, where K is the constant of proportionality. So P is in two parts. The first part is C, and the second part is K root A. That means that P is equal to the first part, which is C, plus the second part, which is K root A, where K is the constant of proportionality. Now we need to find the value of C and K in order to get an expression connecting P and A. We are being told that when the pressure is at 990 millimeters, the cross-sectional area is 2.25 millimeters. So we can say that when P is 990, the cross-sectional area, which is A, is 2.25. We know that P is equal to C plus K root A. So we can replace P with 990 and A with 2.25. When we do that, we are going to have 990 is equal to C plus K root 2.25. Square root of 2.25 will give us 1.5. So this will give us 6C plus 1.5K is equal to 990. This is equation 1. The question also told us that the pressure is 842 millimeters when the cross-sectional area is 6.25 millimeters. So when P is 842, A is 6.25. So we can substitute these values into this equation. When we do that, we will have 842 is equal to C plus K root 6.25. So square root of 6.25 will give us 2.5. This is going to give us C plus 2.5K is equal to 842. This is equation 2. So we have two equations with two variables. We are going to solve these two equations simultaneously for the value of C and K. We will solve the simultaneous equation in the next video. So see you in the next video, and let's continue solving this question. Welcome back. We started solving this question in the previous video, and we got to this point where we had two equations. The first one is C plus 1.5K is equal to 990, and the second one is C plus 2.5K is equal to 842. And we are going to solve these two equations simultaneously for the values of C and K. We are going to use the elimination method. So we will have equation 2 minus equation 1. This will give us C minus C plus 2.5K minus 1.5K is equal to 842 minus 990. 2.5K minus 1.5K will give us 1K or K. And 842 minus 990 will give us minus 148. So K is equal to minus 148. We need to find the value of C. From equation 1, we know that C plus 1.5K is equal to 990. We have found the value of K as minus 148. So we can replace K with minus 148. So you have C plus 1.5 times minus 148 is equal to 990. 1.5 times minus 148 will give us minus 222. So you have C minus 222 is equal to 990. If you group like terms, you have C is equal to 990 plus 222. So C will give us 1212. So the value of K is minus 148 and the value of C is 1212. The expression is P is equal to C plus K square root of A. We saw this in the previous video. And we have found the value of C as 1212 and the value of K as minus 148. So we can replace C with 1212 and replace K with minus 148. So you have P is equal to 1212 minus 148 square root of A. So we now have an expression connecting P and A. The question said we should find the cross-sectional area, that is A, when the pressure is at 770 millimeters. So when the pressure is at 770 millimeters, it means that P is equal to 770. We know that P is equal to 1212 minus 148 square root of A. So we can replace P with 770. This will give us 770 is equal to 1212 minus 148 square root of A. If we rearrange this, that is, I will send this term here on the left hand side, on the right hand side to the left hand side, then I'll bring this one here from the left hand side to the right hand side. We will have 148 square root of A, because when this crosses the equal sign, it becomes positive. Then this will give us 1212 minus 770, because this is positive here, so when it comes here, it becomes negative. This will give us 148 square root of A is equal to 1212 minus 770. And we will have 148 square root of A is equal to 442. So you have 148 square root of A is equal to 442. We divide both sides by 148. So if you divide both sides by 148, you have 148 here and 148 here cancelling out. So you have square root of A on the left hand side. And on the right hand side, you have 442 divided by 148. So square root of A is equal to 221 divided by 74. In order to find the value of A, we need to square both sides. So we have square root of A squared is equal to 221 divided by 74 squared. Square root of A squared will give us A. If you find 221 divided by 74 squared on your calculator and you correct your answer to 2 decimal places, you have 8.92. Remember, the question said we should correct our answers to 2 decimal places. So A is equal to 8.92. This means that the cross-sectional area is 8.92 millimeters when the pressure is 770 millimeters. Thank you for watching this video. Subscribe to this channel for more videos. This is the end of the videos on variation.